Hey, what's up, Algebra 2? It's Ryan. Today we're going to be working on solving rational functions. So, in previous lectures, we've talked about operations with rational expressions. And so we talked about multiplication and division, as well as addition and subtraction. And so then we were essentially just rewriting these rational expressions and simplifying them. But now what we're doing is we have actual equations, and so we're solving for exact values of x that satisfy that equation. And so we're going to be drawing upon knowledge that you hopefully learned in pre-algebra or algebra 1, as well as some of the stuff we talked about last lecture. Okay, so when we're solving rational functions, we have two main methods. One, we have cross multiplication. So we just condense it into a proportion and then we cross multiply, which I'll show that in an example, but hopefully that sounds familiar. Hopefully you covered that in pre-algebra or algebra 1. Our second method is going to be multiplying each side of the equation by the least common denominator and then solving that resulting equation. So last lecture, we talked about identifying and finding the least common denominator. And so we're going to use that same knowledge to help us here when we're actually solving these equations. And then when we're actually solving these equations, we have denominators. And we essentially, when we have x in our denominator, there might be some value of x that makes our denominator equal to 0. And obviously, when our denominator is equal to 0, when we divide by 0, that's undefined. And so we need to check for that. And also just whenever we're dealing with rational functions, we just need to check for extraneous solutions. So after we solve for certain values of x, we just need to plug that back in. Okay, so let's start with question 1. So we have 7 over x minus 6 equals 4 over x. And so how I'm going to decide whether I want to use method 1 or method 2 is based off of our denominators. So I'm going to look, is it going to be relatively easy to find a least common multiple between x minus 6 and x? Well, we'd probably have to multiply the two, and that would get somewhat messy, so it's just easier to cross multiply. And when we cross multiply, that means we essentially take this 7 and this x and we multiply them. So 7 times x is 7x. And that's equal to, when we multiply across in this direction, 4 times x minus 6. So 4 times x minus 6. And then from here, we just want to solve for x. So we have 7x, and that's equal to, we're going to distribute this 4. So we have 4x, and then minus 24. And then we subtract 4x from both sides. We get 3x equals negative 24. We divide by 3 and we get x equals negative 8. Now before I cement that in as our answer, we need to plug that into our equation. So I'm just going to do this out loud, and I know it's kind of hard to see, but we have 7 over x minus 6. So 7 over negative 8 minus 6. And negative 8 minus 6 is negative 14. So 7 over negative 14 is negative 1/2. Now on this right side, we have 4 over x, so 4 over negative 8, and so that's equal to negative 1/2. Both sides are equal to negative 1/2, so we're good. Great. Okay, now let's move on to number 3. So again, I'm going to look at the denominators. We have x and 2 and x. And so I'm going to look and say, is it relatively easy to find a least common multiple between those two? Yeah, we just multiply the two and we end up getting 2x. So I'm going to multiply every single term in this equation by 2x. So we have 2x times 3 over x minus 2x times 1/2, and that's equal to 2x times 12 over x. And then we're just going to simplify this. So here, when we multiply 2x and 3 over x, these x's cancel out. So we're left with 2 times 3, and that's 6. And then here, we're multiplying 2x and 1/2. These 2's cancel out, so we're left with x times 1, so that's minus x. And that's equal to 2x times 12 over x. And again, the x's cancel out. 2 times 12 is 24. Now we just solve for x. So we subtract 6 from both sides, and we're left with 18. We multiply or divide by -1, and so we get x equals -18. Now, before we cement that in as our answer, we're going to have to plug this in and check for extraneous solutions. So we have 3 over x, which is 3 over -18. So that's -1/6. And I'm just going to write this out to the side so I don't forget. And that's -1/6 minus 1/2. Okay, which I'm just going to do that out. If we do least common denominators again, we get -1/6 minus 3/6, which is just equal to -4/6 or -2/3. So hopefully this right side will be equal to -2/3. So 12 over x, or 12 over -18, when we simplify, we can divide both the top and the bottom by 6, and we end up getting -2/3 again. So this checks out, and this is going to be our answer. Okay, now let's move on to 5. So when we look at 5, also generally, well, let me just start by saying this. So when we look at 5, we want to do what we did with the other two problems, even though this looks a lot more complicated. Can we find a least common multiple between all of these denominators relatively easily? Well, let's see. When I look at this, my instinct tells me that 3x plus 2 and times x minus 2 is going to give us something like this denominator here. Let's just check that. So when we multiply 3x plus 2 times x minus 2, 3x times x is 3x squared. And then 3x times -2 is minus 6x. 2 times x is 2x. And 2 times -2 is -4. When I combine like terms, -6x plus 2x is -4x. And that matches up with our denominator over here. So our least common multiple, or our least common denominator, is 3x squared minus 4x minus 4, which is equivalent to this expression up here. So it is relatively easy to find a least common denominator, so we're going to use method 2 here. Also, at least for me, when I see that we're doing addition or subtraction on one side, I'm probably going to lean towards using method 2 and finding the least common denominator. Okay, so here I'm going to multiply every term by this expression, right? So this is going to take a while to write out, but you know what, or actually, you know what we could just do? Imagine we have this entire thing, and we're multiplying this by, no, never mind. Just forget what I was saying there. We'll multiply this by our 2x over x minus 2 minus 4x minus 1 over 3x plus 2. And that's going to be equal to 17x plus 4 over 3x squared minus 4x plus 4, and all of that times, I'm just going to write this, but these two are equivalent. So I'm going to write times 3x squared minus 4x minus 4. Okay, and then we're going to see where we can cancel some things out. So I'm just going to erase this, but you can rewind if you want to see how we got some of that. So I see when we multiply 3x plus 2 times x minus 2 times 2x over x minus 2, this x minus 2 is canceled out. So we essentially get 3x plus 2 times 2x, right? Because when I multiply this out, I have x minus 2 on the numerator now, and I can cancel those out. And so conversely, when we multiply it times x minus, or 4x minus 1, we have 3x plus 2 on the denominator, so that cancels out. And so now we're left with 4x minus 1 times x minus 2. Okay? And then here, we have 17x plus 4 over 3x squared minus 4x plus 4 times 3x squared minus 4x minus 4. Sorry, this is the minus side. These end up canceling out, right? So we're just left with 17x plus 4. And now we just need to do a lot of foiling and combining like terms so we can solve for x. So here, when we multiply these two parentheses, we get 3x times 2x, which is 6x squared, plus 2 times 2x, which is plus 4x. And then this is subtract, and I'm going to put a parentheses around all of this. We have 4x times x, which is 4x squared. Then I'm going to do this next part in my head, but we have negative 1 times x, so negative x. Then we have 4x times negative 2, which is negative 8x. So negative 8x minus x is negative 9x. Then we have negative 1 times negative 2, which is going to be positive 2. And then that's going to be it. And then we still have our right side. So now I'm going to try to simplify and combine like terms. So 6x squared minus 4x is going to be 2x squared. 2x squared. And then we have 4x minus negative 9x, which is plus 9x. So 4x plus 9x is going to be plus 13x. And then we have minus positive 2, which is just minus 2. Again, that's equal to 17x plus 4. Now I'm going to subtract 17x plus 4 from both sides, such that we have 2x squared minus 4x, and then minus 6 equals 0. And then I'm going to factor out a 2. And then factor that inside parentheses. So we're left with 2. And then what two numbers add to negative 2 and multiply to negative 3? Well, it's going to be -3 and +1. So we have x minus 3, x plus 1 equals 0. And then what two values of x make this equation true? Well, we set each of these parentheses equal to 0, and we find that x equals 3 and x equals -1. But again, we need to check for extraneous solutions. So this might be hard to do all in your head, but I'm going to try to do it, and I might make a mistake. You probably should write this down, or write it down when you do it, and definitely on a test I would write it down, just so also the teacher knows you're checking. But let's plug in 3 for x into this equation. So we have 2 times 3. Actually, I'll write it off to the side. So this is what we have. So when I plug in 3 for x, we have 2 times 3, which is 6, over 3 minus 2, which is 1. Then I'm going to subtract 4 times 3, which is 12, minus 1, which is 11, over 3 times 3, which is 9, plus 2, which is also 11. So we have 6 minus 11 over 11, which is 1. So that's equal to 5. And we need to make sure that our right side is equal to 5 too. So we have 17x plus 4, so 17 times 3, which is going to be 51, plus 4 is 55. And then I have 3x squared, so 3 times 3 squared, which is 9 times 3 is 27. 27 minus 4 times x minus 4 times 3, which is 12. So 27 minus 12 is 15. And then 15 minus 4 is 11. So we get 55 over 11. That equals 5. These check out. So I know 3 is a good answer. Now let's plug in -1. So we have 2 times -1, which is -2, over -1 minus 2, which is -3. I'm just going to write those both as positive because they cancel out. And then I'm going to subtract 4 times -1, which is -4, minus 1, which is -5, over 3 times -1, which is -3, plus 2 is also -1. Those cancel out. 2/3 minus 5. I'm just going to rewrite that as 2/3, and then have like denominators of 3, so I'm going to multiply this by 3 over 3, which is just 15 over 3, and that gives us -13 over 3. So this is what our right side should be equal to. If you can still see, I know this is getting really small, but okay, so 17x plus 4, so 17 times -1 is -17, plus 4 is -13. And then 3 times x squared, 3 times -1 squared. And so -1 squared is +1. 3 times +1 is 3. And then 3 minus 4 times -1, which is -4. So 3 minus -4 is going to be 3 plus 4, which is 7. And 7 minus 4 is equal to 3. So we get -13 over 3. Those two are equal, so we know -1 is good. Now, in all of our examples that we did today, we did not have an extraneous solution. But it will come up, and I bet it will come up on some of these other even problems. So please, every answer that you get when you're solving rational functions, please plug them in, check for extraneous solutions. That's all we have for today. But if you have any questions on what I did here in this lecture, or something related to rational functions, please reach out. I'm happy to help. Use me as a resource. That's why I'm here. Definitely also reach out to your teacher. Talk to some of the kids in your class or in other periods who feel pretty comfortable with this, and maybe even upperclassmen or siblings, and definitely use the internet and YouTube and all these different resources to support you so that you feel comfortable with solving rational functions so you're ready for your test and your quiz. Okay, great. Thank you for listening, and I hope you have a good day.